Regardless of how far our telescopes advance, we will always be unable to see the universe's starting points, as indicated by Albert Einstein. Anyway, a new revelation made by the James Webb Telescope has caught something unprecedented that might be firmly connected to the enormous detonation rather than to stars and worlds. It shows up that Einstein's instinct was presumably right. How might we potentially notice an occasion that appears to have transmitted no light? In addition to the fact that it happened in complete dimness, yet it was additionally gigantic to the point that it opposes our actual appreciation. As per winning speculations, there are inquiries concerning whether this would be able to actually be the start of everything we know. This momentous revelation could give us significant responses about our reality and shed light on the circumstances that won in the early universe. Our universe started as a small point around 13.8 billion years ago because of a little inconsistency. The peculiarity broke free from a condition of amazing balance and eventually formed into the universe as we probably are aware it today. Curiously, remainders of this unique point can in any case be found inside black holes in our universe, where the gravitational forces act. These black holes are strong to such an extent that their insides approach boundlessness, befuddling our strategies for estimation. The James Webb Telescope, NASA's most recent space observatory, has now caught pictures of a black hole and a huge void at the dawn of time, possibly going before the appearance of the principal stars in the universe. Just imagine the early universe, not long after the Big Bang. A seething, thick blend of particles and radiation expanding at an astounding rate. At this stage, there was no customary light as far as we might be concerned because photons, the crucial particles of light, continually connected with thick free protons and electrons, unfit to navigate space uninhibitedly. It took around 380,000 years after the Big Bang for the universe to cool off to the point of permitting the arrangement of the principal impartial particles, principally hydrogen and helium. As the cooling advanced, photons acquired the capacity to move uninhibitedly, giving rise to the inestimable microwave background. Anyway, the universe stayed in obscurity since there were no light sources like stars or worlds. Yet, a few 100 million years after the Big Bang, the course of reionization initiated with the development of the first stars in quite a while. These youthful, hot stars transmitted extraordinary ultraviolet radiation, which ionized the encompassing impartial hydrogen atoms. The ionization of hydrogen atoms brought about protons and free electrons, increasing the universe's penetrability to ultraviolet and noticeable light. Gravity was the main impetus behind the production of the earliest stars and worlds, constraining gas mists, particularly those containing hydrogen and helium, to consolidate. Inside these consolidated districts, pressure and temperature increased to where atomic combination ignited in the centers of these first stars, creating light and enlightening the universe for the first time. Their brilliance fundamentally added to the reionization cycle, steadily delivering the universe more straightforward. The radiation produced by these stars and systems was intense enough to ionize the thick obscurity of impartial hydrogen that had invaded the universe until that point. This continuous process continued until the whole intergalactic medium was transcendently ionized, connoting the finish of the Dark Ages and the introduction of the universe as we as of now comprehend it. In this manner, even with the most advanced telescopes, our perception is restricted to the moment that the universe became straightforward and light could unreservedly spread. Up to this point, researchers had assumed that this achievement happened roughly 380,000 years after the Big Bang. The James Webb Space Telescope, famous as the most progressed and strong telescope to date, is determined to uncover the insider facts of the universe's starting points. Furnished with 16 honeycomb-shaped mirrors and cutting-edge infrared innovation, this remarkable telescope catches light signals that have headed out to us for an astounding 13.5 billion years. It has currently taken huge steps by finding old cosmic systems and presently has made another, absolutely exhilarating viewing as a black hole that existed a simple 500 million years after the Big Bang. Black holes are basically patches of huge void absent any trace of matter, yet they have an exceptional property, gravity, that permits them to draw in encompassing matter in an apparently supernatural way. You could think about how something apparently void can convey such weight. This disclosure challenges our comprehension of the early universe and the objects it contained. This specific black hole, however not among the biggest known, is surprisingly old and abnormally huge, tipping the scales at around 10 million times the mass of our Sun. Researchers made sense of this by recommending that either the perplexing dark matter or the course of black holes consuming matter causes them to acquire mass. Analysts have found a staggering black hole that is developing at an extraordinarily fast rate, leaving them bewildered regarding what is causing it. On the off chance that we extrapolate the development rates seen in present-day black holes, this specific black hole would need to be more established than the actual universe, which appears to be inconceivable. Anyway, we can't totally preclude the likelihood that a few components of our universe existed in a foreigner universe. Dark matter, like black holes, is undetectable, but its presence is derived through its gravitational consequences for spacetime. It is additionally plausible that black holes in the early universe had altogether unique attributes from those we have concentrated on very close. James Webb's series of spellbinding disclosures have shaken laid-out hypotheses and uncovered defects in our ongoing comprehension of cosmology. Huge black holes that develop at remarkable rates in cosmic systems that seem to originate before the universe challenge the groundworks of recently acknowledged hypotheses and computations connected with the Big Bang and its result. Researchers presently face an impressive test, one that may prompt a total reassessment of our cosmological perspective. New speculations are arising, and old ones are being returned to. For example, the hypothesis of variable actual constants suggests that the regulations administering the universe at its initiation contrasted essentially. Basic actual constants, for example, the gravitational steady or the fine structure consistent, may have had completely various qualities during the beginning phases of the universe. Such varieties could make sense of the quick development of cosmic systems and the serious extension of black holes. While the overall hypothesis of relativity depicts powers and occasions on a tremendous scale, including gravity, the hypothesis of quantum gravity looks to accommodate Einstein's hypothesis with the thoughts of quantum mechanics. It is an interesting move toward that merits conversation. The field of quantum mechanics looks at the conduct of microscopic particles and the powers working in that area during the beginning phases of the universe, close to the Big Bang, when everything was tiny and thick. While Einstein's hypothesis of the largest phenomena was essentially utilized by researchers to form the Big Bang hypothesis and compute the early advancement of the universe, there might have been blunders presented by this jumble. James Webb's revelations presently give proof of such disparities. In summary, researchers are right now confronted with a complex enigma that requires unwinding. George Lemaitre first alluded to this as the speculation of the early-stage molecule. American space expert Edwin Hubble's perceptions in the last part of the 1920s uncovered that far-off galaxies were retreating from Earth at quicker speeds, really intending that the distances between them were expanding. While quite a bit of this understanding depended on perceptions and estimations, we presently experience peculiarities that do not fit flawlessly into these fundamental suppositions, which researchers deciphered as proof of the universe's extension over the long run. Extra speculations were then consolidated to supplement these underlying suspicions, at last molding our cosmological perspective. Unique hypotheses exist in regards to the arrangement of the main black holes, and researchers are effectively exploring this subject to acquire a superior comprehension of the early universe. Anyway, inside these laid-out examples and systems, the exact timing of the primary black hole developments remains a subject of progressing examination and investigation. One winning hypothesis suggests that the principal black holes formed from the remainders of gigantic stars, known as populous 3 stars, which seemed 200 or 300 million years after the Big Bang. These early stars, remembered to be brief, may have taken their lives in epic cosmic explosion blasts, possibly leaving behind black holes as remainders of their monstrous blasts. What's more, there are perceptions of very monstrous black holes that existed in the early universe, with masses going from millions to billions of times that of our Sun. Researchers are as yet incapable to make sense of how these black holes achieve such gigantic sizes in such a brief period. This hypothesis proposes that black holes might have shaped even before the first stars under particular conditions, turning dust plates that had the potential to frame stars could implode straightforwardly into black holes. As indicated by one hypothesis, they might have begun as a consequence of more modest black holes consolidating with bigger ones as they absorb matter. Anyway, this hypothesis needs the presence of stars and matter falling into the black holes with its uncommon powers. The James Webb Space Telescope has the possibility to uncover more about the early universe than some other telescope. By looking further into space, it can see the principal galaxies and quasars, which are fueled by really gigantic black holes that function as a sort of time machine. The telescope gives us an immediate look into the secrets of the early universe by permitting us to inspect light that was delivered billions of years prior. Cosmologists are confronted with a major secret and the need to track down answers for address inestimable conundrums. As the James Webb Space Telescope uncovers the secrets of the early universe, the puzzling production of the principal black holes presents itself as a fascinating infinite enigma that pushes the limits of our information and urges specialists to study the secrets that exist at the intersection of space. As we dig further into the universe's initial stages, researchers are likewise investigating the effect of dark energy, a puzzling power that drives the sped-up extension of the universe. The possibility that the universe could have been more permeable in the past drives speculation about the potential presence of dark energy in the early universe. Understanding these elements may assist researchers with assembling the pieces and acquiring significant knowledge into the creation of black holes and their impacts on cosmic development. As this field of research proceeds, researchers will keep on investigating the connections between black holes, cosmic development, and the universe's history, revealing insight into its beginning stages, the nature of dark energy, and the intricacies of cosmic structure. In this dynamic field, progress in observing techniques, for example, those gave by the James Webb Space Telescope, will keep on pushing the limits of what we can learn about our universe, from its most established black holes to its farthest galaxies. The disclosures made by James Webb remind us that we are only at the beginning of this cosmic voyage, and that the universe still holds numerous secrets waiting to be uncovered.